Thank you. So let's write that. 1 over sine theta. The moment they give you such, you convert them to the one that you know. So cosec is 1 over sine p. We have to maintain the sign, the letter. Times. Then what about sec?
Times 1 over cos.
Thank
1
you.
over cos b.
Thank you. 1 over cos b. Thank you. Minus cot. What is
Which
cot?
is 1 over tan.
Yes, now look at this
But
now.
there's another
Yes, the moment you write sine and cos, don't give me tan because you'll be introducing a lot of different things now. You have to give me now in everything in terms of sine and what? And cos.
in cos.
So which is going to be
So
what?
it's cos theta over sine theta.
Thank you. So here we use cos b over
Cos
sine
b.
b.
Hey, I've been writing theta the entire time.
Yeah, it's p. They gave us p. So now, look, man, you are just like this. And then the only thing that they want to check from you here is, let's do fractions, man. It's solving of fractions. That's all they are doing. Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson.
Make use of trigonometric identities to prove that sec squared x multiplied by cot squared x is minus 1 is equal to cot squared x.
Okay, cot squared x. So just look at the way I wrote it. Is it fine like this? I know here
Yes.
they put a dot, maybe they put it like this.
Yeah, they like dots. No, they put it that way. They put it with the
A
multiplication.
multiplication sign. Okay, so they put a multiplication sign here. Alright, so it's sec squared x times cot squared x. There's no bracket, just like this.
Just like that.
Okay, perfect. Alright, is equal to this. And then how many mark allocation there?
4.
It's 4 marks. Okay, so also
Yeah,
it's,
but the difficult things 4 marks.
yeah, it's 4. Usually they give them even 6, man. So 4 is, with trick 4, you say on the proofs, it's fair. You know, it's fair. Now, let's look into this thing. As I say, I will be working to, I have to work with this in mind. Let me bring this. I have to work with these formulas. Let's look at the formulas first, because that's where, as you say, we have to always go back to our formulas. What is it that they will provide in the formula so that I don't have to worry, like you don't have to worry about cramming some things that are already there. So this is the formula for the trick that you have. And this is, okay, fine, your sin theta is 1 over cosec. These are your basic ones, right? To say your sin, your cos, and your tan. So remember that there is one way. And then the identity that is very important. I want you to look at this identity. Cos squared theta plus sine squared theta is equal to 1. It's the base, the beginning. This you must always remind yourself as the base from 10. Actually, these two identities, they are the basis of trigonometry. Whenever you are introducing yourself to trig, this is what you start. But now I'm interested in the one of sine squared theta by plus cos squared. If I take cos to the other side, what do I have? I have got sine squared theta is equal to what? 1 minus
Cos theta.
cos squared
Cos
theta.
squared.
Please remember this. And the other thing, it works also for cos. If it was cos on the other side, it would be 1 minus sine squared theta, right? And then also remember, this is a difference of two squares. Those two things you must always remember. This is 1 minus cos theta, and this is 1 plus cos theta. Always remember this kind. They always bring them around to confuse you about in this. Whether it was the other way around, it would be 1 minus sine theta, 1 plus sine theta. Are you with me? And then these other identities, as I say, if you see, like for example, if you see sec squared theta and 1 plus tan, these ones you don't have to cram them, you just have to refer to them whenever you see sec squared appearing. So let's look at this question here. It says, the one you gave, I think it's here. It says sec squared theta plus, times cot squared theta minus 1. Now be careful. You see this multiplication sign? This multiplication sign does not allow you, if there was an identity like this, you're not allowed to use it like this because there is no brackets, you see. So you follow BODMAS, meaning multiplication first before subtraction. So for example, let me write it like this. If I gave you this, I say sec squared x times, then I say cos squared x plus sine squared x. You know that this is 1, right? But the way they have written, you cannot make this thing equal to 1 now. I don't know whether I'm making sense.
Yeah.
Look, this is 1. This is 1. This, provided this does not exist, it's 1. But the moment I say times, you have to follow the rules of BODMAS, meaning you cannot now, this is start here before there. You see now?
Yeah.
You understand BODMAS now? You cannot now say, I'm taking this and use it in an identity. This will be 1 times sec squared x. You cannot. So it means you have to first multiply what? Sec squared times cos first, BODMAS. Then you will say plus this guy. All
So
right.
they purposely left out those brackets.
Yeah, if they put the brackets, then work out the brackets. But if it's like the way they've
No,
done
I mean, like, they left the bracket of the sec squared x and the cot x.
intentionally, yes, they left it intentionally so that you can be tempted to say, is this an identity? And then you come and try to apply an identity here. So let me see, do we have an identity of cot squared? Let me see here. You see, we've got an identity of cot. You see this one? But don't be tempted, no, even though it's not the same, but don't be tempted to try to apply an identity like that when there's a multiplication sign. But what do you do here? Let's come back to say, what must you do? Because there was nothing here, there was nothing here. Let's apply the normal working here to say multiplication comes first. Are you with me? So obviously when you're proving, you tell us which side. So I'm going to take my left hand side. So now sec squared, you remember what is sec squared? You have to convert it. It's 1 over cos. Sec is 1 over cos. Alright, and you have this from your what? From your formulas. We just looked at it. Here, there is sec. Where is sec? Sec theta is cos theta. So it's the other way around. If I give you sec, you also interchange it. I think that.
Yeah.
Yeah, so here on this, if I say cosec, it will be 1 over sine. So these are, one is the inverse of the other. You understand? Yeah. So here it means we have got 1 over cos, but it's 1 over cos squared. Alright? Times, what about cot squared x? Let's look at the identity again. For cot squared is what?
10.
Cot squared.
1 over 10.
Yes, but there is this one. Look at cot in terms of sine and cos.
Oh, you must put it in cos and sine.
Yes. It's better like that because already I've expressed the other one in terms of cos, you see? So once I've expressed this other one in terms of cos, it's better for me to automatically say this is cos squared x over sine squared x. I think that. And then from here, I just have to, I think already is clear. I must, okay, I say minus 1. Let's not forget, this is minus 1 here. And then from here, what do? I have to cancel out. This already shows me that this goes. I think that.
Yeah, that just becomes a 1 sine squared.
1 over
sine squared x.
Then minus 1. Are you with me? But now, remember we have to go there. So let's continue now. What do? You remind yourself what is.
It's now a fraction game.
Yeah, this fraction. But what is 1? What is 1? Maybe we can work on 1 there. 1 is what? 1 is...
So it's 1 squared. We must make it a difference, but we can't do it.
A difference of 2 squares? No, we want to go to cot. Look, let's take this thing to the top. What does it become? Remember, 1 over sine. 1 over sine is cosec. Remember? It's cosec. Am I right? 1 over sine is cosec. Let me take you there. Look at 1 over sine. Remember the opposite here.
1 over sine.
So if
cosec.
if sine theta is 1 over cosec, meaning 1 over sine. Remember this, you interchange. If I say here 1 over sine theta is same as cosec theta. Are you getting that?
Yeah.
So that you have to interchange. It's like the one is the inverse of the other. If I say 1 over sine is cosec, if I say 1 over cosec, it's sine. It's the inverse of the other. Are you finding?
Yeah, I'm fine.
So now, which means if I say to us here, what is 1 over sine squared? Do you see that this is cosec squared x? I think that minus what?
-1.
Minus 1. And then from there, we go back again to the identity. Look at this look at this one. There it is. If I take 1 to the other side, it becomes what?
Becomes a -1.
Cot squared theta is equal to what?
Cosec theta -1.
Cosec squared theta minus 1, which is what we have that side. You see? So that's cot squared. Look at this. We have it already. This is cosec squared x minus 1, and cosec x minus 1 is equal to what? Cot squared x. You see, from that identity. There it is, like cot squared theta.
Manipulating these formulas.
Yes, like you have to be comfortable with the formulas, but you have to see. Okay, let me come back to this, Abel. I think I understand now. Let me just do a little bit here. Let me come back to this formula again on trig ratios here. If I say to you, remember, if I say sec, you must link sec theta to cos. You agree with me?
To cos, yeah.
Sec is linked with cos, but what is it? It's 1 over cos theta. You agree with me?
I agree with you there.
Now, if I say to you cosec theta, you must know that cosec is linked to what?
No, cosec
Is
linked to sine.
Sine. You see, this is the part. And then, when I say to you, as you did cot theta is also 1 over 10, as it did. You understand? So these must be also something that you like. I mean, if I say start with sec, cosec, cot, but the good thing with the formulas, they don't give you the sec, cosec, and cot. They give instead the sine, the cos, and the tan. So you will have now both sides to say, I know sec is 1 over cos, but the formula said cos is 1 over sec. You see? You see the difference there?
I see that difference.
So you start from these other ones whereby is the inverse one, the sec. Knowing it from the sec, converting it into normal cos. Knowing it from cosec, converting it into normal sine. From cot into normal tan. You see the conversion. So if you've got this starting point, it doesn't make much of a change because you will now know then, okay, if I know this version, even the formula now knows it the other version. So the formula here says 1 over sec, it's cos. 1 over cosec, it's sine. But just know that the inverse is true. Okay. So then that then becomes something that we will prove from that. And then let's look at this one also here that I have. It's similar because it is dealing with this part. Let's write this one. Look at this one. It's also format. It says what? Cosec b. I want us to do together this one. Cosec b times sec b
minus cot b is equal to 10b.
Is equal to 10b. So don't forget, you need to specifically tell me that you are taking the left hand side and then work it from there. Just the just say left hand side because the left hand side is the one that we can simplify here. So look at this. We take the left hand side. What do you think?
I don't know. Maybe the trig ratio maybe could work.
Yes, yeah. Or the moment they give you cosec, go for trig. Go for the actual one. What do you know cosec to be? What is cosec?
Cosec is 1 over sine
Thank
theta.
you. So let's write that. 1 over sine theta. The moment they give you such, you convert them to the one that you know. So cosec is 1 over sine p. We have to maintain the sign, the letter. Times. Then what about sec?
Times 1 over cos.
Thank
1
you.
over cos b.
Thank you. 1 over cos b. Thank you. Minus cot. What is
Which
cot?
is 1 over 10.
Yes, now look at this
But
now.
there's another
Yes, the moment you write sine and cos, don't give me 10 because you'll be introducing a lot of different things now. You have to give me now in everything in terms of sine and what? And cos.
And cos.
So which is going to be
So
what?
it's cos theta over sine theta.
Thank you. So here we use cos B over
Cos
sine
B.
B.
Yeah, I've been writing theta the entire time.
Yeah, it's B. They gave us B. So now, look, man, you are just like this. And then the only thing that they want to check from you here is, let's do fractions, man. It's solving of fractions. That's all they are doing here. Remember, this guy is multiplying. So it's more like, here I have got 1 over sine B cos B. You see that?
Cos B.
So what is the common denominator?
The common denominator for all of it. Because now we're subtracting it.
Yes, we're subtracting, yes.
Now we're subtracting, it's going to be sine B over cos. No,
Thank you.
Sine B cos B.
Thank you. Sine B cos B. That is the common denominator. You agree with me? So listen. And by the way, trig, man, works like everything. Algebra is still algebra. You don't have to change when you're in trig. It's still algebra. All right. So let's do it now. What do I write on top?
So we've got 1 times. What does this guy have? This guy's got a sine B, so we need a cos B. So cos squared B.
1 minus.
We're minusing. Why am I thinking multiplication?
Yeah. So it's 1 minus what? 1 minus cos squared B. Perfect.
Cos squared B.
Cos squared B. Thank you. Now, pay attention now. Pay attention. Already the answer is there. What do I do? Just pay attention. I just gave you a hint previously, but just pay attention. Remember, you're going to 10. Already something good is given there. 1 minus cos squared. What do you see there?
1 minus cos squared.
What do you see there?
Like that. Oh yeah, 1 minus cos squared is equal to sine squared.
Thank you. Remember, sine squared B plus cos squared B is equal to what? Is equal to 1. Remember this identity.
1.
Yes. So obviously they are trying to check, are you aware of the other version of it? Are you seeing? So there you agree that it's sine squared there. So it's sine squared B over what? Sine B
over sine B cos B.
Cos B. And then what's the next thing? We have to cancel out, right?
Well, the signs will cancel out.
So now how many signs do we have there? Remember, it's sine squared. So let me write 2 of them.
We've got sine
times. It's more like sine
B
times
over
sine.
cos B.
Yeah. So it's more like I've got sine B times sine B there. So I'll cancel the first. I'll cancel this one, and cancel this one. So I've got what? Sine B over
Cos B.
Which is what? What is sine over cos?
It's a tangent. Sine over cos is equal to a tangent.
10b, which is our what? That's what we're proving, which is our right hand side. So that's it, man. Which is our right hand side.
The only thing you have to do in proving identities is just play with the formula.
Yes, play with the formulas, man. Yeah, don't think far, but at the same time, when you're playing with the formulas, you see fractions and everything, but when you're playing with the formulas, just see the end though. Don't run away from the end, you know. So for example, they give you like 1 minus cos squared, and then someone can do this from here. Let me show you this. It's still fine, it still works, but you know, you make life difficult. Do you see where they say 1 here? Someone will say, I know what is 1. Someone will come and say, where there is 1, I'm gonna put this one, sine squared plus cos squared. So you'll come here and say sine squared b plus cos squared b. But it's good because cos squared and this will subtract. You see that thing? But it's like you're taking the longer routes and the longer things, and sometimes you might get yourself confused. But one way or the other, they must take you back to the answer though.
So there's no reason to make it a difference of 2 squares here, because it doesn't.
Thank you. You see, thank you. Now let me show you. Now you're talking what I'm talking about. Think of it here. You are here, and now because Sabilo had, I said make it a difference of 2 squares. Now you're here saying 1 minus cos b. I know this is a difference of 2 squares. 1 plus cos b. My question is, yes, you are right, but is it helping you solve what you are solving here? Yeah. It's not solving it. It's making you further away, but still you are correct. Because from here, you know what you're going to do? You're like, okay, I think I did wrong. Let me open the bracket again, which is back again to 1 minus cos squared. So you might find yourself thinking you're doing things, but you're running in circles, right?
So there's no need to play with reduction angles here, because what I was going through in the morning.
The reduction angles, they're there. I wish we have got, as I'm saying, I'll pull out a question that involves that. Definitely you need now on the reduction angles, man, I want you to get that, because that's where they bring like maybe 6 marks questions there. Because they can bring a simpler question just because they needed you to know a little bit on the reduction angle. That is important. That is important. All right. So, but I will pull one. I'll check quickly one before the end. On our break time, I'll just call a break, then pull one or so that we can do. I'll actually look for 2 questions that involve proof, so that we can again get into that. And then there is another one. 4 marks says calculate the value or values of x. Also an important one. See, calculate the value or values of x that will satisfy this equation. 4, you see they give you that between 0 and 360. Now this is important again. Let me write this thing down. You are saying here, they are saying here 4 cos squared x plus what? Plus 4 sine squared x is equal to 5 minus 10x. See, they're just confusing you there. Nothing much here. They're just confusing. Now, talk to me. What is it? What do you see?
This one is tricky. This one.
Nothing tricky, sir. No, nothing tricky. Nothing tricky. They're just playing with your eyes. Nothing tricky here.
They're playing with my eyes, but I mean the first thing.
Talk to me about this side. Talk to me about this side. Talk to me about the left-hand side.
Yeah, I'm looking at that side. I was gonna pull out
the what?
That 4.
Thank you. Let's do it. That's it. Let's pull it out.
I'm gonna have sine squared. Sine, what is it? Am I right?
Yeah.
Yeah, sine squared plus cos squared is equal to 1.
You see now, you have gotten it already. So it's 5 minus 10x, right? And you know that this thing, you are saying this thing is equal to 1.
You've left it behind. I'm still looking at formulas and you're flying.
Okay. No, I thought you were actually telling me to say the cos squared plus sine squared thing.
Yeah, no, I was telling you what I'm thinking.
Okay.
Yes. Okay, now that's equal to 5 minus tangent x.
So, okay, let's look at this one. So, are you fine with what I did there in the bracket?
Yeah, but fine. Yeah, this is equal to 1. So, this is practically just 4 times 1.
Thank you.
So, this 4, we've got it like this. That whole thing can go since it's 1.
Thank you.
I'm like, it's 4 times 1.
Yes, 4 times 1, which is a 4.
So, this is just 4 times 1. And I thought this stuff was difficult.
That's what I'm saying. When you were telling me, I thought already you were saying, when you say pull out the 4, that's why I was pulling out the 4 and factorizing it already, you know, to say I'll pull out the 4. So I already pulled out that 4, and then this remains inside. So what they were confusing you there is the 4 and the 4 there.
But wait, what am I solving for? Values of x.
Yes. So it will be 4 is equal to 5 minus 10x, ne?
Yeah, 4 is equal to 5 minus 10. But what I can do, I can have a positive tangent on one side.
Yes.
I can have 5 minus 4 on the other side.
Okay, yes. 10x is equal to 5 minus 4. Which is equal to?
Yeah, 1.
Thank you. Now,
so 10x is equal to 1. Then what do I do here? I do that inverse 10 thing to get the value.
Thank you. Let's do that. Inverse 10 thing. So that's arc10. So x is equal to arc10 1. Which is equal to what?
This is not that bad. 10, that reverse 10 thing, 1, 45.
Now look at this. Now look at this. Let's go to the question. What did the question say? The question say to you, calculate the value of values. You see the tricky part there? Now, meaning there can be more than one value. So this is the thing. When you do this, please remember, when you do this, you must know whatever you got is a ref angle. Like last time I told you with that,
reference.
Yeah, this is a reference angle. It's the answer, but it's not the final answer also. But it's the answer. So what you do is, let me pull in, draw back my cast diagram. Now in my cast diagram, if you still remember, it is 0. You need to have this every time you solve a trick. You write it once and then all your trick will be dependent on this thing. So this is this, remember, it's cast. You see, All students take chemistry. This is my quadrant 1, my quadrant 2, my quadrant 3, my quadrant 4. Are you with me? Now look at this. When you are dealing with 10, and you saw that 10x was positive, as you say 10x is equal to 1. Here you say 10x was 1, meaning you expect the answer to be a positive. It's a positive 1. Am I right? Now you have to go now to your what? To your CAS diagram and ask yourself, there are two areas where 10 is positive. The first one is in quadrant number 1, and the other one you can see is in quadrant number 3. Do you see that? Now in quadrant number 1, that's where you get your ref angle. So you are covered. This is your 45 because it's less than 90. But there is another answer that is in quadrant number 3. And the reduction rule of quadrant number 3, it says what? 180 plus theta. So your theta is your ref angle. So you are going to say the other value, or x is equal to 180 plus 45. You see that? And then you get your answer there. That is two answers that you're supposed to get.
225.
Which is what?
225.
225 degrees. Now let's prove this thing. Let's go to the original. Do this for me. Put this, say 5 minus 10, 10 what? What was the first one? 45. Say 5 minus 10, 45. Do the right hand side.
4, we've got 4.
4, you know this other side is 4 already. Remember, it's cos squared plus sine squared is 4, right? And then say 5 minus 10, 225. The other answer was 225.
5 minus
10, 225. This other answer, what do we call? Remember, there are two answers. 225. Yeah.
Also 4.
You see, so those answers. There are two values that will satisfy that equation because 10 is positive in quadrant 1 and quadrant 3.
So if I've only got 1, I've got a half mark.
You get half mark. You're not gonna get all. You'll be 3 marks out of 4.
3 marks, that's not bad.
But why lose it, man? I mean, already I'm trying to show you to say here you're already closer to the answer. You have done all the heavy lifting and everything, and the other thing is just to say plus 45.
I'm saying it's just a small thing you forgot. It's not like those situations where you...
Yeah, no, they will definitely give you marks because, as I say, the heavy lifting has been done already here. All this is marks that they give you. Up to 45, you get your 3 marks. The last one, I mean, there is nothing done. You can see, I just said 180 plus 45. It's you recognizing that there must be another part. All right, now let me change it like this. Let's change this question. I'm interested in this question. Let's change it. Let's make this question like this. Instead of having this one, let's redo this question, and I pull this and say minus 5. I want to show you something.
Minus 5.
It will be 4 cos squared x plus 4 sine squared x is equal to minus 5 minus 10x. Let's solve it like that. How do I change this working? Let's change this working. 4 cos
squared x plus 4 sine squared x.
There's something important I want to show you.
Minus tangent. Okay, so let's see what we can do here. So it's going to start in the same way as the previous one.
Thank you.
Factorizing that.
Thank you. Factorize for me.
Sine squared x. So that's done. We've got minus 5 minus tangent x. Then what do we have here? We've got 4 times 1. So you go to minus 5 minus tangent x. Then we've got... this is getting to the interesting part. So I can take that minus 5 that side, but I'll still have a minus tangent here.
Let's maintain the same. Take tangent to the other side. Still fine.
Yeah. Yeah, well, but none. Oh yeah, if I take tangent to the other side, tangent x, I'll have minus 5 here and minus 4.
So it will be minus 9, right?
Yeah, that's now minus 9.
Thank you.
That's tangent.
So let's find our x. What is x?
So x is the inverse 10, whatever that is, of 9, which is, let's see what that is, of 9, gives us 83.660.
Did you use 9 or minus 9?
I think I used the wrong number there.
Check again.
Negative
Remember, it was
Yeah.
10x is equal to minus 9. So what are you finding? Did you find for 9 or for minus 9? I want to know the answer I'm
I
calling.
found for minus 9. For minus 9 is 83.660.
A positive or no negative? For minus 9.
Negative.
Okay. Now look at this. As I said in the analytical, you always find your reference angle, remember? And when it's negative, ignore that negative. Always say, this is what you write. You write ref angle. It's always in the first quadrant, so it must be positive. Are you with me? So you're going to say ref angle is equal to arc 10, 9. Just ignore that negative. I'm going to explain why. So find for me arc 10, 9 is 83 point what?
660.
660. Now, why did I ignore the negative? This is the thing. The reference
Oh,
angle...
yeah. Negative, it would have fallen into the fourth quadrant.
Yes, thank you. So I'm here now. 83,660. Are you with me? But now, what is this negative telling you? This negative is telling you that when you're solving for this question, you must go to two quadrants where 10 is negative. And what are those two quadrants? It's quadrant number 2 and quadrant number 4.
Then quadrant number 4.
Then it says, go use that reference angle and the reduction rules of each quadrant, you'll get the answers. For example, what is the reduction rule of quadrant number 2? It's 180 minus theta. Am I right? And then what is the reduction rule of quadrant number 4?
Minus theta.
Is 360 minus theta. Guess what is your theta? Your theta is your reference angle.
Okay.
So now give me the answer now. What is the answer? Say 180 minus 83.660.
So 180 minus 83.660. Not worth using my brain over 83.660. What do you have? We've got a whopping 96.340.
96.340. Give me the other answer, or the one with 360 minus that same thing.
Minus 660 is equal to 180,
360 minus 83.660.
276.340.
276.340. These are the answers now. If I can say, let's put in the same answers here. If you say 5, if you say here minus 5, just do the same one, like the one that you just got, 276. Just say minus 5 minus 10, 276, and tell me the answer. It must give us 4.
Minus 5
minus 10 minus 276.340. It must round off to 4.
4.
What is it giving you?
4.
You see, that's it, man.
Like I'm far. Can you hear me okay? It's like I'm far.
I can hear you well. But are you able to hear me clearly?
Yeah, I can hear you.
Yeah, no, it's fine, man. Actually, the sound of the last 2 days was a bit... It's like you were in air. Like, this is so clear for me, eh? Your sound.
Is this clear?
Very clear. The sound of the last 2 days is like you were outside. Someone will think like you were connecting from like outside where there was air and wind blowing, you know.
There must be the headphones.
Okay, but this is so clear, very clear. Like the first day your sound was like this, and yeah.
So it was only nonsense the past 2 days.
Yeah.
Oh no, actually, yeah. Yesterday the past few days I was also.
Yeah, it was when it's outside, the wind also catches through the earphones. Yeah. So look, man, let me do this. I'm saying whenever they give you a question, this is what I want you to remember. The question is given to you not to cram. Yes, Sabela. Don't cram this trick, but analyze. And you are analyzing it through the quadrants. If after you have solved everything, this is the most critical stage here. See here what I'm highlighting here. So you will solve everything, and then you have now your final answer to say either sin x is equal to this. Just check yourself. If it's negative, just pause and say, my answer is going to be in the quadrants where sin is negative, but I still need to find my reference angle. Then that reference angle, you're going to use it in the reduction rules.
So now if I use that 3 as my reference, I don't get any marks.
If you leave it as 83 like that, unfortunately you get 2 marks because you never gave us the actual angles. Because there, you see the actual angles was 96 and 276, but your working was still good. It can give you up to 2 marks here.
So I would have wasted time.
Yes, you understand. So you must use that benefit of that. And again, if you put minus 7 minus the negative in it, it's still possible. You'll find some other people, lecturers and everything, they still work through that negative, but you need to be aware what must you do if ever there is that negative and if there is a positive. You understand? So my approach has always been, let's go through the reference angle. From the reference angle, I can find every other angle that I'm looking for.
Yeah, mathematics.
Are you fine? Are you understanding that part? If it is positive, guess what? Already the reference angle is part of the solution. Remember, we got in the first one we got a positive answer. So the reference angle is already part of your answer. That's why you asked me already how many marks. I said 3 marks. Why? Because it was positive and automatically that's your reference angle at the same time. But don't stop there, because there is another answer where 10 is positive. The only challenge is when it's negative and you get a reference angle which is always positive, is like you still need to find your 2 answers, you see, because they are in the other quadrants. All right.
Yes, sir.
Okay.
No.
Fine. Okay, we'll pull in a few part of this, and then I don't know. Are you interested in this 6.3? I'll bring in a question again on this trick.
How many marks is this one? Let's see.
This one.
ABC 7.
This one was how many marks? Figure these. What do they want? Let me do to the next. Yeah, it's 5 marks. It's continuing.
What do they want?
They want determine the following: the length of AC and angle ADC. The length of AC. They want AC. They want this one. And ADC, and they want this thing. Let me check again.
Yeah.
Let me check ADC. Yes.
Yeah.
Anything coming?
So,
yeah.
Well, this is interesting. What do we have? So trigonometry can work here. Then.
Thank you. As long there is no right angle. Let's check though. I didn't read this question actually. It's good to read this thing. They say figure below represents a quad, right? A, B, C 70, AC 60, 4, 5. So there is no right angle. So trig ratios are not gonna work.
Trig ratios are not gonna work, but we're given lengths.
You are given lengths, which means you are in this cosine and sine rule.
So the cosine and sine rule can still work.
They always work in triangles that have no 90 degrees. Okay.
Cos and sine. If cos and sine can work, most then I'm still in this.
Come again.
What do they want? They want AC, and I've got one sine. I don't know how to work this out. I can only work out the angles.
Okay. Let me see. Let me see here. They're saying it's what? Maybe I'm also not reading this thing properly. Figure this represents the quadrilateral. A, B, C is this. A, B is 4. This is 4. Okay. This is X. Yeah, man. Alright, yes. Focus on this guy. Let me show you. Focus here. Focus on this. Focus on this. And focus on this.
Yeah, that's where I'm at.
And then you look for a pair. Once you get a pair, an angle and the side, that's already sine.
So I can go sine across like that.
Yeah, look at it. As I said, how do you spot sine rule? What you do is, remember, I said when you are naming triangles, if I give you a triangle like this, and I say the way you name, if it's A, B, C, you agreed that A is the small a there, this is the small b, this is small c. You are fine with that, right?
Yeah.
Like the sides, to say, is it too small? Like this side, this is side C.
That's
yeah, that's fine. Now, what I'm saying is the same thing here. If you have got an angle here, which has got its side, which is 4, then you have a pair. At the same time, 70 degrees and x, that's another pair. So if you apply your sin A over A is equal to sin B over B. So this formula, you see, it talks about A and the side, it talks about B and the side, it talks about C and the side. Do you understand what I'm driving it?
Okay, so that's reference to A. So A will be there. Okay, then someone sine A is equal to sine.
Come again.
So that was sine A and sine B.
So yeah, what we want, yes, is sine. Actually, what we want is sine C and sine B because it's angle C. So we can say sine B over side B is equal to sine C, that angle, over side C. Are you seeing that?
I'm seeing that, but this is one of the questions I would have just let go.
Okay, now it's that's why they made it 2 marks. It's a matter of looking at a pair. So when I give you an angle and I give you its corresponding side, you must know sine rule is in place. Why? Look at it. There is an angle and the corresponding side. So what do? I say sine B. You can see sine B is sine 70 over B. That's what I want. This B is the AC. That's what I want. Over AC is equal to sine C, which is sine 60, over what? Over 4. You see that? And then from there, I solve for P. This is what you do. You cross multiply. This multiplies, that multiplies. So you say 4 times sine 70, 4 times sin 70 is equal to AC times sin 60. And then how do you find AC? Divide by sin 60, divide by sin 60. Then that's what you have your AC there.
Yeah. So it's just algebra.
Yeah, algebra. So what do you get there?
4 times sine 70 over sine 60. 4 times sine 70. What do we have? I've got a syntax error. Maybe I did something wrong.
Yeah, just check. Yeah.
Calculator's not as smart as I thought it would be.
What has it
complaining because I forgot to put a bracket.
Yeah.
4.340.
4.340. 4.340. See, so you've got that side. It's using the sine rule. And then the next one.
Sign.
Yeah.
The next one.
So you know the sine rule is in your formulas, am I right?
No.
It's there, man. Look, there. You have it.
It's not written sine rule.
Yeah, where is it actually? Why is it not here? Wait. This, unfortunately, this question paper didn't have the sine rule. Why is it?
Oh, there it is, down there.
Is it there?
Oh, it doesn't have the sine rule, but it's got
there,
the sine rule.
Yeah, this one. That's the sine rule. Yes, it's there, man. This is the sine rule.
Yeah, for crying out loud.
Don't forget, this is the sine rule, this one. And this is the cosine rule, this one.
So all these values are equal?
Yeah. If the rules say if you find an angle A over side A is equal to angle B over side B equal to angle C over, I can give, if one is missing, you can find it through the rule.
So what I'm calculating here is a length.
Is the length, you see? And you are given 2 angles, which is good, and a side, you see? So you are given an angle and a side. Already, once you get an angle and a side, you must know I must do the sine rule because I got an angle and I got a side. And usually, if you see those 2 questions like that, one is 2 marks, the other one is 3 marks, chances are the other one will be the sine rule, the other one is going to be the cosine rule. You understand?
Then the next question wants us to do what?
The next question wants us to find angle D.
Angle D? Angle D? How must I smell angle D? Okay, let me think.
Think.
But now we don't have an angle now on this side.
Okay, let's try the pair. Let's try the pair. Remember, we want this and this. So we don't know this one. So already, if you don't have a pair, unfortunately, it's the cosine rule.
It's the cosine rule.
Yes. Now, can you say out the cosine rule for me? What do you have there? I'll show you how you go about it.
You don't have the cosine rule in this.
You have it, this one. Okay, this one. This is the cosine.
It's the same as that one.
This one. A squared is equal to b squared plus c squared minus 2bc cos a.
That's the cosine rule.
This is the cosine rule. And
Okay,
so remember also to go through that lesson also, there is a question that covers a sine rule on yesterday's lesson, right?
Yesterday's lesson.
Yeah, there is a question that wants that. So just go through it until the end.
I stopped when I got to identity, so I'll go through it until the end, see what's happening.
There is this area actually. So, and actually, you know what, man? Actually, I see now, even that exam of yesterday, there is a lot of solving for the angles. You know, when I told you about reference angle and stuff, I think I did 4 questions there, if not 3.
The reference angles one and stuff.
The one that we just calculated just before this one.
Yeah, I'll finish it off. I wanted to be done by before this lesson, but I ran out of time.
Yeah, I understand. So look at this, man. This is called the cosine rule, and here it says a squared is equal to b squared plus c squared minus 2bc cos a. What is a, b, and c? Those are sides. You understand? These are sides. So meaning, let me show you this how this formula works. If I give you a triangle, remember these are used where there are no trig ratios that are applicable. This is for triangles that are not a right angle triangle. Okay, so if I give you A and I give you B and I give you C like this, so this formula is saying if this is A, this is B, this is C. This formula, that's what it's saying. Read the formula. It says A squared, which means this side when you square it is equal to B squared plus C squared minus 2bc cos A. Look at the link. When you start with A squared, you will have an angle of A. Do you see that? Do you see the pairing there? But follow the formula. So let's come and follow the formula this side. Just as is, we'll follow it as is. Look at this. We have got a triangle, and our triangle is like this. Just like this. Just like this. Then the formula says, let me write the original one so that we can take it from there. It said A squared is equal to B squared plus C squared minus 2. You multiply B and C, which is BC, but it's cos the angle of that beginning, which is cos A. So now let's apply here. We are interested in D. Do you see that? Angle D, which means I'll say D squared, because it starts with a small side, is equal to, which is this D, is equal to what? C. See, this is C and this is A. Do you see that? So it is going to be as A squared. Let's start with alphabetical order. A squared plus C squared minus 2. I must multiply A and C. So 2AC cos what? Cos D. You understand? That's how you get your angle. Now what you do is algebra again. What is D? D is what? Tell me what is D? Yes, there 4.340 squared. Don't forget this is squared. Is equal to A squared. Yeah, A squared is what? 6 squared plus C squared is 5 squared minus 2AC, meaning 2 times, you multiply please, times 6 times 5, and then what?
Times cos D.
I'll write it in this so that it shows different. Cos D. Then from there, please don't use a calculator at this stage. I'll show you how you get your final answer once. Don't touch a calculator. So what you do is this. Do you see this side is negative, right? There is a negative sign. So take it to the other side so that it becomes positive. So you have got what? 2 times 6 times 5 cos D. You see that? Is equal to 6 squared, leave it like that, plus 5 squared, what?
Minus 4.
Thank you, you're following there. But squared. From there, divide both sides by what? 2 times 6 times 5. You see, don't simplify things there. Your calculator will do the job. 2 times 6 times 5. It's not worth it doing it slowly because It's just 3 marks. Look, now how do you write the answer? Remember, you're looking for D. Then you're going to say D is equal to arc cos this whole thing. 6 squared plus 5 squared minus 4.340 squared over, you see how I did it once? 2 times 6 times 5. But arc cos, can you find me arc cos of that?
It's arc cos of a big one.
Yes, but it's good, man, because you just do it once and then you get your answer. It's 3 marks, man. You don't want to be, what can I call it? You don't want to be massaging a 3 marks, man, into like it's a big thing, you know. Just work it and go. So
yeah, it's a big thing if you've missed out on a lot of.
Yeah, I understand. No, I'm trying to say, look at the work that you have done on top. You have been working. Yeah. So to be making it so long, like you're working for the 6 marks, why don't you just pull in everything once and get your answer? I understand. Because what students do, they want to change that 6 squared, 5 squared, 4.3 squared. Then it's become a big number. They start ending up making errors along. If you are good, it's fine. If you've got all the time, you know what I mean. But I'm saying it can be done once, you know.
So we've got ourselves 45.353 degrees.
You see, if you can do this, that's it. 45 point what?
353.
Okay, let me confirm it with mine just for accuracy so that we are all together. Shift arc cos, and then it's 6 squared plus 5 squared minus 4.340 squared, and then all over 2 times 6 times 5, and then like that, equal to, you see, that's it, man. I don't know, my take is it's more quicker to get my final answer like that, and then I'm done, because there are no marks, by the way. Okay, let me remind you how they are going to mark you. They are going to mark you based on this thing. Number one, they are going to mark you on this part here, cutting it properly. See this? Remember, it's 3 marks. So they'll give you a mark for that, to say you did the first line. Secondly, they are going to mark you by making your D, one way or the other, either this D or making D the subject of the formula here by dividing so that you remain with this cos D. They'll mark you that. The rest, then they are looking for the final answer, because there is no other marks to give, like, you know, in between, because it's just they are mean with cos. It's 3 marks. Unfortunately, the working is long, but they still have to give you 3 marks.
There's a lot of work to do in entering. It's hustling.
Yeah, I know. But as you say, every mark is important. You can't just take it for granted, right? All right. So that is the part there on this part. And another thing that I wanted you to check with the graph sketching, I didn't do graph sketching on that side. Are you comfortable with graph sketching?
Yeah, graph sketching really is not that bad, especially if you, because I didn't really pay attention to the different graphs and shapes like that, but stuff like that is not that bad. As long as, because the formula will tell you what it is.
Yes, so you use the formula calculator version, and then you have your points, and then after that you sketch. So
yeah, because all you need to know is those y-intercepts.
Yes.
And stuff like that. So analytical is not that bad for me. When it's simple, get quick marks, and
okay,
because it's always the same thing. It's always the dfx of the f of x of the turning point.
Yes, and then
the same thing.
Okay, the one I'm talking about, Sabel, is also for trig. Are you fine with those trig graphs, right? Because here I'm in 6.4. Look at 6.4 is the graphs, but under trigonometry.
Same set of x's. Between 0 and 180.
Are you fine with this one? Or you want me to
let's go to this one. Me, I'll skip this one.
Okay, that's the one. When I'm talking about graphs, no, those ones were passed because you did tell me those ones. We did a bit, but I'm interested in this type. So look at this. Again, your calculator will give you your answer, right? So let's start with the first one. Can you put this in your calculator? And then for me, I'm gonna do this quickly. This table of values here.
What's the one where you rob like this?
Come again?
So one way you can rob with the table.
Yes, but you do draw. What you do, okay, I'll show you. Just a moment. So what you do is, because I'm supposed to draw 2 graphs. So the first one is my normal x. So let me do these. Okay, let me do one after the other. Let me not mix things here.
Yeah, just
Yeah,
both. It's fine.
it's fine like this.
What
Yeah,
you're doing.
let's do this. So what we're gonna do, you will tell me the values that you are getting there. It's just that I'm avoiding it. I'll tell you why I was avoiding that. But now let's start with f of x.
This one is fine because it's starting from 0 to 180,
Yeah,
so you can.
we can. Yeah, it's not much. Yeah. So
But what intervals are you? 30 intervals or
H, that's the thing. You see, it's better to use 15. Like, let's do it. So take a calculator there. Let's take a calculator,
right?
and then in
And
the
then start
calculator
from
you've got
what?
what mode?
Or go to table mode.
Yeah, mode, table mode, which is number 3, and then you write f of x is 1/2, and then sin alpha x. Where is my x there? You find that?
No, I'm still looking for x. Found my x. Yeah.
So alpha x then equal to start. They told us where do we start from? From 0. So equal to, and then end.
Sorry, mine jumped.
It's fine. It's fine. If yours have a g of x, if yours have a g of
mine
x,
has
now the good thing. Wait there. Don't. Yours is even more. Yours is more intelligent than mine. So don't change there. Let's go back. Let's start from the beginning. I'll tell you what to do there.
Right.
Say f of x is called 1/2 sin x.
Yeah, and then g of x. Do I enter?
Yes, enter your g of x. You see, enter your g of x there, which is minus 2 cos alpha x again.
Okay, and then enter. Start 0.
0. And 180.
108
equal to step, please use 15 unless it gives you an error. Always, you know why 15 has got 45 and 30, you see. So it covers 15 covers all the special angles, the 45 one and the 30. So you get these. So these are the values you have. The good part is you have got f of x and g of x. You need to give me all the values you are saying there. So let me start from 0. What are you having for f of x?
0. F of x, I've got 0. G of x, I've got -2.
Okay, give me the next one. Number,
I've got 15.
What do you have for 15?
I've got 0.129.
Okay, the other one.
-1.93.
Yeah, all those that are commas, let's leave them. I need the one that are solid numbers, either 0.5 or 1 or 0.5. Yeah. So.
But you know that the issue is that it has solid numbers on the g of x, and then
it's fine.
On the,
no, it's fine. It's fine. Give me those. As long as there's g of x with a simplified but no f of x is fine. Give me the one. Give it to me because I need to cover for g of x.
Okay. X. Okay, so we start with f of x or g of x.
All of them. Just if there is 30, tell me. Then I'll write under g of x. If f of x has got it, I'll leave it out. If f of x is not.
Okay, then we've got 30, 0.25.
Okay, or under f of x.
Under f of
okay,
x.
Not bad. 0.25 as is like that. That's the end.
That's the end. And then g of x is -1.732.
I'll leave it. Let's leave that one. Next one.
Okay. Then 16. 16, we've got 0.443 on f of x, -1 on g of x.
-1. So this one we'll leave it out. Okay.
And then if we go to 19, we've got a half on f of x and 0 on g of x.
Okay.
And then what is this? 120.
Yes.
We can skip f of x, and then we've got g of x is 1.
Okay.
Okay, and then let's go to 150. We've got 0.25 on f of x, and then we skip g of x. 180. We've got 0 on f of x and 2 on g of x.
So that's it, man. And then at this stage, remember, this is just a sketch. So I'm just going to put it down there. This is a sketch. So what we have is this. We pull it like
I just put all the numbers there.
Come again?
we just put on the solid numbers rather than having to put on the 0.5 and
yes, those comma, too much comma numbers, like, yeah, just even if the comma is there, but it must be, you can see that this is 0.25, you know, it's a special angle.
yeah, this is
yeah, because it was half. Actually, it was supposed to be 0.5. Because of that half, it's becoming 0.25, you see. But if you've got a lot of commas like 4, 5, just ignore them, because they don't, you'll still draw your graph. They are not necessary. So when you're drawing, remember, this is telling you is from, why am I drawing it like this? I don't have a negative x, you see that? My x is from 0, so there is no reason for me to go to the center and draw a graph that doesn't have a negative. Okay, but I have got a negative 2 and a positive 2 on the y side, so I have to have a positive and a negative. Then from there, it's up to me how I'm going to do that. For example, I can even make it long, this one here. Let me do this. I can make this longer. Let me try to take it a bit down. Yeah, make this have more space and try to be like this. All right, then from here, don't forget y and x are important. They will penalize your marks for getting such. And then from there, what you do is you're trying to measure to say this is my 1, that's my 2, my 1 again, this is my 1, this is my 2, but on the negative side. And then you divide it nicely evenly here for the 180 to say here, what are you having? We say it is 30 from 0. This is 60. From 60 is 90. And then what? 120. Am I right?
Yeah.
150 and 180. That's what it was giving me on these values. If it was giving you numbers with 45 and stuff, you also have to play around, but still this is fine because 45 is between 30 and 60. You know, it's not a problem. So now we can plot this. Look at this. If you say it, the first one I'll use red, f of x, let's plot the graph for f of x. There it is, 0, 0. 30 is what? 0.25. So I've got a half, which is half of half. So it's there. Then the next one is 60, I jump. 90 is half. 90 is somewhere there, half. Then where's the next one? 150, 0.25 is back to that one. And then 180 is 0. You see that is just a nice curve like this. You see that? You see that? That's, then you label it f of x, of f. Then we come back to g. I'll use a different one there. 0 is minus 2. There it is. Sorry, minus 2. I'm starting from the bottom. There it is. And what? What else do I have? 60 is negative 1. It's somewhere there.
Then we have 90 is 0. Then 120 is 1.
120 is 1.
And then 180 is 2.
180 is 2. So it keeps, you can see how it was like, but it's like a curve. Don't forget cos. It's like a curve that does this. You understand? Because cos is more like, you see, remember these graphs are waves, you know. So don't now try to make a straight line out of this thing. Cannot be a straight line. So you must see the way it was shaping. You can actually see, even if you try to make it a straight line, it's trying to show you the shape itself. You see, you're forced to make a curve. So if you follow the dots, you come there and you'll be forced to make a curve. But they will mark you for the shape, eh? So please be careful there. Show us that this thing is not a straight line, and then they mark for the shape of the graph. Then also don't forget to label it to say this is the graph of g of x. And then let's look at the all parts there. They say show the coordinates. Very important now. You want the 6 marks. It says show the coordinates of the turning points and the intercepts with the axis. So the intercepts, by doing this now, this -2,
yeah,
that's good.
This is better, yeah, because now if they want the intercepts with the x's, it's right here on the thing.
Yes, thank you.
Because we have 0, we've got -2 on the y.
Thank
so
you.
My intercept 0, 2
is indicated. Now, what about the turning points? Show me the turning points here. What will you write? Let's start with f of x.
The turning points here.
For f of x.
For f of x, no, maybe it's 90.
Thank you. But coordinates, remember coordinates of the turning point.
Yeah, 0 and 90.
90 and what?
90 and
we come.
is that a half?
Yeah, let's come to the table. It was 90 and a half. That's it. So 90 and a half.
And it's actually on the thing. It's on the table.
Yes. And then what about the other one for g of x? Where is the turning point for g of x?
The g of x, hey, this one is tricky because there's like two of them.
That's what you must write, not one. You must write those two.
Because we've got the one at the bottom there on 60, and then we've got
the one. Which one? Which one?
On 60, I don't know if that turns or not. 60,
no,
but nothing.
No, there can't be a turning point in the middle like that. No.
So it's there at the top.
Yes, the top. I agree with you because it's about to turn. You see that this thing was about to turn. So there it is. It's 180 and what? It's 180 and 2. There is another turning point. Where is it?
On this graph, the one that we currently have.
On g of x.
On g of x, I don't know. There's no.
There, man. On -2, that's a turning point. -2, 0 and -2. That's a turning point there. They were trying to trick you there. This graph was gonna turn from here.
But also that 0 must be the turning point. On 90 and 0.
On 90 and 0. No, let me check. You might be right. Let me check here.
If you look at the table.
Yes. Can I write this one? Let me write this one. We said what is the turning point here?
90. The number is x is 90.
Okay, this one is 0 and -2. Okay, this one. So you're saying this graph, you are right actually. You are right. So this graph was gonna be let me see. This graph was gonna do this. This graph was gonna do. Now it was yet to 10, man. It's not a turning point.
Well, because if you look at the
you see, the thing is, if it turns, there is the thing. You must understand how these graphs are. If it turns at half, it must also go and turn at half in the other side. Look at this one. It turned at 2 and -2. Do you see that? Then if it turns at half, so even here, somehow I must go to another half where it is going to turn, but -half. Do you understand?
I understand.
So this is not a turning point. It was still going down.
And then on the g of x, on that 90. So actually the table is misleading.
The table is what?
The table is misleading. You can't get all the answers from the table.
Yeah, the table can't tell you the turning points. It's the shape. The table was just telling you to say, for example, when you said 90, since I was not clear here what was that value, I was saying refer to the table. At 90, what did we have? You know, that was just that. Yeah, it was just to refer to say what did we have.
On the table, if you look at f of x, on 90 we've got a half. It started from 0, went to a quarter, went to half, back to a quarter, and back to 0 again. So half is where it turned around.
Thank you. Yes, that's good.
And then for the g of x, it starts from -2, then goes to 1, gets to 0, and then goes down again.
Then it goes up, which means there's a turning point.
There should have been Hey, but these questions are nonsense.
Yeah. But what you do? Just do this with what you call this when you're dealing with trig, right? This kind of things. Always remember we call it the amplitude. So if you identify that, you agree that this is a turning point, and you're saying the distance here is 2. You agree with me? So it means it has got another amplitude somewhere. There is the other one, 2 there. You see that? That's why you can easily say this is an amplitude. So even here, the amplitude of this other one is half. You see that amplitude? So you need another amplitude down there to get another turning point. You understand? Because there is no way now it can turn back there. Because now it means it doesn't have an amplitude. You see that? When it turns there. And then it also can't turn there like this. Are you seeing that the graph won't be uniform?
It would have changed.
Yeah, it would have changed.
It will have 2, what is it now? Equations.
Yeah, it would have, It's more like you have got 2 graphs within a graph. In a way, the graph is now like an error. So you expect it to go a little bit on the negative again. So if it was continuing, it will go down. And so that it maintains the amplitude of -half. Again here, it must go down so that it maintains that amplitude of -half there. So which means this is just an intercept and that is just an intercept. But let me give you especially on the hint. Cos, always remember, cos is easy to get to turning points. The one in the intercepts is also usually a turning point if they give you cos. Just be sensitive there.
Cos graph, sine graph,
Yes.
trig graph.
Yeah, so you are not going to deal with 10. Always focus on cos and sin. All right.
Yeah.
Okay, so
If I have the time